Then we are coming to one or two numericals. Sometimes you may have a question that why refractive index of air is 1. Now see there, I have not placed a unit because refractive index, as I said earlier, doesn't have a unit. Actually, the velocity of light in vacuum is slightly more than the velocity of light in air. But for calculation purpose, magnitude of velocity of light in vacuum is taken as equal to the velocity of light in air. And that value is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. You can just imagine, put 8 zeros over 3 and you will understand what it is. Or 3 into 10 raised to 5 kilometer per second. Now 3 into 10 raised to 5 means 3 lakh kilometer per second. That is the velocity of light. When 1 second, light travels around 3 lakh kilometers. So having known the velocity of light, we can therefore calculate what is the distance between us I mean earth and the earth's moon, or we can calculate what is the distance between earth and the sun, or what is the distance between earth and the stars. Now there we are calculating on the similar manner on the basis of the velocity of that light wave or velocity of the radio wave. So here I have shown the calculation: refractive index of air, velocity of light in vacuum to velocity of light in air. Both the values are same, so ultimately it comes out to be 1. So therefore refractive index, absolute refractive index of air is 1. Now another sum I have taken: light enters from air to glass having refractive index 1.5. What is the speed of light in glass? Speed of light in vacuum is given. Now we know that n is equal to c upon v, where c is 3 into 10 raised to 8 meter per second. So v is equal to, if I take v over there, this eta will come down. So c upon refractive index. So c upon n. So 3 into 10 raised to 8 upon 1.5. If I simplify this, I will get 1.5 into 2 is 3. So 2 into 10 raised to 8 meter per second. That is the speed of light in glass as per this particular given numerical. So such numericals can be asked in examination. Do remember. Now as we had Cartesian sign convention for spherical mirrors, Cartesian sign convention of spherical lenses can be asked. So figure goes similar as we had drawn for that case. In case of mirror, here also we have drawn a figure. There is a convex lens placed in the center, that is O. Whatever the distances that are measured in the direction of incident ray from O, they are taken as positive. Whatever distances that are taken against the direction of incident ray, they are taken as negative. Whatever the height of the object that is found above the y-axis, that is positive y-axis, are considered positive. Whatever the height that are taken below, they are taken as negative. So 6 points have been mentioned. Do remember those 6 points. All the distances are measured from optical center of the lens. The distances measured in the same direction as the incident ray are taken as positive. The distances measured in the same direction opposite to the direction of incident light are taken as negative. The height measured upward and perpendicular to the principal axis is taken positive. And last, height measured downward and perpendicular to the principal axis is taken as negative. Then we are talking about lens formula. As we had mirror formula, we have stated earlier what mirror formula was. I hope you all remember. We had 1 upon u plus 1 upon v is equal to 1 upon f. That was mirror formula. When if it is put in words, we say that the relation that gives, the formula that gives the relation between object distance, image distance and focal length of a spherical mirror, what we call it as mirror formula. Here we are talking about lens formula. The formula that gives a relation between object distance u, image distance v and focal length f of lens is called lens formula. There was plus sign between the two Here we are getting minus sign. Do remember the distinction between mirror formula and lens formula. Here it is 1 upon V minus 1 upon U is equal to 1 upon F. Then comes about magnification produced by lens. Now again the definition goes similar. The ratio of height of image formed by the lens to the height of the object is called magnification produced by lens. Magnification M, that is height of image to height of object, which we write it as h dash upon h. In terms of V and U, we have M is equal to V upon U. So there in case of spherical mirror we had M is equal to minus V upon U. Here we have V upon U. Do remember the differences between the two. Do not get confused, because while you are solving the sums, these values are going to be important. Now note, M is positive for virtual images and M is negative for real images. We are now coming to one numerical based on it, and that is the numerical is 10.3. It is given on page 182. Now solution is: a concave lens always forms a virtual erect image on the same side of the lens, and that's why position of the image that is given as 10 centimeter, we will write V equals to minus 10 centimeter, because it is on the same side, left hand side of the optical mirror, optical lens. Focal length is also negative, so f is equal to minus 15. We want to find out object distance. Using lens formula, we have lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. So if I keep this here only, so minus 1 upon U is equal to 1 upon F minus 1 upon V. If I multiply both sides by minus sign, this minus will become plus, this will carry minus sign, this will become minus minus plus. So I write this first, so 1 upon V minus 1 upon F. Having placed these values, we get 1 upon 30 minus 1 upon 30. 1 upon U is equal to minus 1 upon 30. That's for U is equal to minus 30 centimeter. And we know that objects are always placed on the left hand side of the lens or mirror. So their sign is going to be negative. And that's why we get U equals to minus 30 centimeter. In other words, we can say object distance is 30 centimeter. Now then comes about magnification. M is equal to V upon U. Let's place the value of V and U. So V is minus 10, U is minus 30, and therefore it comes 1 upon 3. 1 upon 3, that means it is third. It is 1 upon 3 times the size of the object. 1 upon 3 times, very small, and that we have already seen in the diagram even. Then in concave lens, whatever the image that is formed is smaller. So positive sign indicates image is erect and virtual. Image is 1/3 the size of the object. Do remember and do try to do the sums which are given. Let's come to the final point, final topic of the chapter, that is power of lens. Power of lens is defined as it is the reciprocal of the focal length. The reciprocal of focal length of lens is known as power of lens. In other words, power P is equal to 1 upon F. Now just imagine what may be the unit of power. F is measured in meter. So 1 upon meter, it may be per meter or m raised to minus 1. But here we are telling unit of power is diopter and it is denoted by D. We can measure power of lens by using diopter meter. Note, power of concave lens is positive and power of convex lens is positive and power of concave lens is negative. When you happen to go to optician for taking out your spectacles, then there on the basis of power, whether the sign of power is positive or negative, the lens can be decided. If the positive power is there, the lens is going to be convex. If negative power value is there, then the lens is going to be concave. So this you can make out from the sign, positive or negative, whether the lens that you are wearing is concave or convex. Think about two statements. You may be asked why. Okay, so do remember about why this positive sign and negative sign. This completes the chapter of light, reflection and refraction. Okay, do practice, do draw the diagrams which are given. Diagrams are very important. Diagrams may be asked in question, so ray diagrams must be drawn clean and neat, and practice those diagrams. Diagrams are easy, only the thing is that practice is required. Okay, so see you then. Stay home, stay safe, and do ask if you have any query. Okay, thank you.